If your biological phosphorus removal keeps failing, look at the RAS line first. RAS, return activated sludge, is pumped back from the secondary clarifier to the biological process. In a BPR system, that RAS passes through or near the anaerobic zone. And if it's carrying nitrate, your BPR is in trouble. Here's why. The anaerobic zone needs to be truly anaerobic. No dissolved oxygen and no nitrate. PAOs need that environment to take up VFAs and store them as PHA. That's the step that makes luxury phosphorus uptake possible downstream in the aerobic zone. When nitrate enters the anaerobic zone through the RAS, two things happen at once. PAOs divert their VFA consumption toward denitrification instead of PHA storage. And ordinary heterotrophic bacteria compete directly with PAOs for the same VFAs, using that nitrate as an electron acceptor. Both mechanisms drain the VFA pool. BPR fails. The nitrate comes from the secondary clarifier. The higher your RAS ratio, the faster you're pulling sludge out, the less time it has to denitrify in the blanket, and the more nitrate arrives in the anaerobic zone. Research showed a 14 percentage point RAS ratio increase produced a 56% increase in RAS nitrate load, far more than the proportional flow change. There's also a nighttime problem operators miss. During low overnight flows, influent drops, but RAS pumps can't go below their minimum flow rate, so the actual RAS ratio spikes, sometimes above 200%. That nitrate surge hits the anaerobic zone while nobody's watching. Morning BPR performance is degraded, and nobody knows why. The fix is managing RAS rate with BPR in mind. Lower RAS rate during warm weather when nitrification is most active. Give the clarifier sludge more time to denitrify before it returns. Monitor for phosphorus release in the RAS line. When it appears, the clarifier is anaerobic enough to protect BPR. One research finding worth knowing for the exam: facilities with a total nitrogen permit limit had significantly fewer BPR failures, P equals 0.024. Plants managing nitrate for their nitrogen permit were simultaneously protecting their anaerobic zones. Nitrate management and BPR protection are the same problem. Know your RAS rate. Protect the anaerobic zone. BPR follows.